In this video we're going to be doing some math with matrices. A matrix is the single version, and when we have more than one matrix we have matrices. So there's our single and plural version. A matrix is a rectangular arrangement of numbers or data. So here's an example. We use these brackets to contain what are called entries in our matrix. And so we could have some values like that. So here we have a matrix. This is specifically called a row matrix because it only has one row. Rows go from left to right. That's how we define rows. And we would call this matrix, we could call it A. Say that matrix A is this table or this set of data. If we start putting in more entries, and these are called entries. Any number inside our matrix is called an entry. Say we add another row. Sorry, just insert another row. I don't want to use add. So now we have a little bit more complicated matrix. It's not just a row matrix anymore. Now it has a size. And the way that we describe the size of a matrix is by listing its row by the number of columns. And we haven't talked about columns yet, but columns go up and down. Where do I want to write that? Let's write it over here. Up or down. Up and down. So this right here is the first column. Here's our second column. Here's our third column. We think about columns in buildings as being vertical support structures. Hopefully that'll help you remember the difference between a row, which goes left and right, and a column, which goes vertically or up and down. So the size of this matrix would be the number of rows. Well, we have one row here up at the top, and we have a second row at the bottom, so we have two rows, and we have one column, two columns, three columns. So this is a 2 by 3 matrix. Alright, so let's keep talking about just what matrices look like and their little characteristics. So just like we had a row matrix, we could also just have a column matrix. And a column matrix would be a matrix with only a column in it. So there's one column. Now it's kind of confusing because, I mean, you could say that this has 1, 2, 3 rows and one column. And when we talk about its size, we actually do say that. We say this is a 3 rows by 1 column matrix. But because there's no other entries in either row, and it just looks like a column, then it's only described as a column matrix. The names of these specific matrices, it's not really important. We haven't really gotten to the important stuff yet, but it is important to be able to talk about matrices in all of these different ways. Let's do a couple more special ones. Just what do they look like? If the number of columns is the same as the number of rows, then we have a nice little square matrix. So again, the number of columns equals the number of rows. And that is a square matrix. It has a nice square shape. So that's a little easy to remember. And the last special one would be if all of the entries in our matrix for all zeros, then we have what's called a zero matrix. Again, hopefully that's pretty easy to recognize or think about the name. What size does this zero matrix have? Well, it has 3 rows and 3 columns. So actually this is a square zero matrix. It has the same number of rows as columns, only zeros as entries. It's possible to be defined as multiple special characteristics or properties there. So square zero matrix, if we want to be super specific about it. Anyways, those are just some characteristics of matrices. Let's talk about how to add or subtract matrices. The one rule that you must always follow in order to add or subtract matrices is this rule. You can only add or subtract if they have the same dimensions. So only if their sizes are exactly the same. If that's true, we can add or subtract. But if they're not the same dimensions, then what we'd have to say is anything like not possible or not the same dimensions. And sometimes you will see problems where they try and get to add matrices or subtract matrices with different dimensions. And this is what you got to tell them. It's not possible. Adding and subtracting matrices is a lot easier than multiplying. So in this video we'll just focus on adding and subtracting, and in the next video we'll get into multiplying. Let's say that our first matrix has these entries, and we want to add that to another matrix with those dimensions or entries. So make sure you look at their size. This is a 2 by 2, 2 rows, 2 columns. Again, 2 rows, 2 columns, so another 2 by 2. We compare their sizes, they're the exact same. We can go ahead and add their entries. And all you do is you just find corresponding entries. So we look at our top left entry here. That would be first row, first column entry. And look at the corresponding entry over here, the top left, first row, first column. And we do the math. So 4 plus 2. And that sum is going to be the answer entry in our outcome here. So we would put 7 as the first row, first column entry. Move on to the next corresponding spots. Top right here, 0 and 3 are corresponding, so we combine those and write their sum as the outcome total there. Again, go to the bottom left or second row, first column. -2 and 0 correspond, so let's add those together and write our sum in the outcome matrix. And again, last entry 1 and -2, that adds up or combines to make -1, and so the sum of our two matrices is this matrix. So really you're just combining corresponding entries, and that's about all it is. The trick, and the thing that might make it a little tricky though, is when we get to subtraction, and let's just make a couple matrices here real quick. So just like how subtraction sign sitting outside some parentheses, if we were to have, let's say, -1 outside, something like that, we would have to make sure and distribute that negative to everything inside the parentheses. Well, matrices work similarly. If you have a negative sign sitting outside a matrix, you must distribute that negative sign to each of your entries. So we could do that. We could say that this is a plus, and that we are now adding -2, -6, and the opposite of a -7 would be +7, opposite of a -1 would be +1. And we could now add our two matrices together here. That's one way to look at it. It's not totally necessary, but if you prefer to work in that method, go ahead. But we can continue doing what we started doing in our last example, which is just following the operation here. So rewrite your matrix with the combination of our entries. So 8 minus 2 is going to be in our first spot. 3 minus -7 is going to be in that second spot there. 4 minus 6 there. And 0 minus -1 is our last entry. And then just simplify and come up with your outcome. So 8 minus 2 is 6. 3 minus -7 is really the same as 3 plus 7, so that's 10. 4 minus 6 is -2. And 0 minus -1 would be the same as 0 plus 1, so we just get +1. So just make sure you distribute a negative that's outside a matrix the same way you would distribute it if it were outside a set of parentheses. And basically that's how you would add or subtract matrices. Just combine their elements, their corresponding entries. One last thing I want to talk about is a thing called scalar multiplication. A scalar is a number that sits outside a matrix. And just the same as we distributed our negative sign, we are going to distribute a number outside a matrix to every entry inside. So we could think of this as a problem similar to this, where we distribute that number on the outside to everything on the inside. So we would say that our first entry is going to be whatever 2 times 3 is. Our second entry here would be 2 times 0. Down here we would have 2 times -2. And then we would have 2 times 4 right here. So 2 right there. And then just simplify to get your outcome. 2 times 3 is 6. 2 times 0 is 0. 2 times -4. Oops, 2 times -2 is -4. There we go. And 2 times 4 is 8. So that's how we would do scalar multiplication. And this thing right here, that number that sits outside the matrix, is called the scalar. Nothing more complicated than that. Alright. Last thing I want to talk about really quick, if I can here, is PEMDAS. How does PEMDAS apply to matrix math? Let's say we have a scalar out here, and this is really inside parentheses here, and we're asked to do some addition inside the parentheses. PEMDAS still applies, just the same as it would anywhere else. So we would have to do inside the parentheses first. That means we're going to do our addition of our matrices first. So we'll leave that scalar outside for a minute. 1 plus -4 is -3. -2 plus 5 is 3. 0 plus 6 is 6. And 3 plus -8 is -5. So we do inside the parentheses first. Now we can move on to multiplication and multiply our scalar to everything. Distribute it. -2 times -3 is 6. -2 times 3 is -6. -2 times 6 is -12. And -2 times -5 is +10. And so there's our final answer, doing a couple different steps there. So inside the parentheses first, and then multiply your scalar or distribute your scalar. So there's a few examples of adding and subtracting matrices, and also using a scalar to distribute. Good luck practicing that as the beginning of your matrix math.